All right, welcome back. This is going to be our second to last section. I do not promise that it is the second to last video. Maybe it will be. We talked about invasive species before. We're talking about endangered species now. This is a review a little bit of what we've already talked about, so a little bit more examples and how it relates to humans and how we are causing or trying to fix these problems. So the cause of endangerment could be natural. A natural cause of endangerment could come from starvation, being outcompeted, excessive predation, a natural disaster, losing its habitat through natural means, impediments to mating. These are all possibilities of how endangerment can occur naturally. So the megalodon shark was outcompeted for shrinking food supply. Species go extinct. Species become endangered without human impact. But there are also anthropogenic causes of endangerment. So HIPCO is what you want to make sure that you remember. You need to remember HIPCO. You need to know HIPCO. You should be aware of HIPCO. HIPCO are all of the things that humans are doing that cause endangered species. HIPCO stands for habitat destruction or degradation or fragmentation. Invasive species, pollution, population growth, climate change, and overexploitation, which could be like overhunting, overharvesting, or overfishing. So that's HIPCO. So what makes a species especially prone to endangerment and extinction? Well, it depends on the characteristic of the species, its use by humans, and essentially what kinds of things what kinds of things will cause it to go endangered or extinct. So for instance, if it has a low reproductive rate as a K strategist, it's going to be more likely to become endangered. If it has a specialized niche, because obviously not having a wide tolerance range, it's going to cause you to have less ability to compete. Narrow distribution, if it feeds at a higher level on the trophic level, if it has fixed migratory patterns, if it's rare, if it has commercial value to it, or if it is a species that takes up a large territory. These are all things that could cause endangerment and extinction, or make them more prone. So selective pressures are just factors that change the behavior and the fitness of organisms within an environment. Selective, like natural selection, will lead to evolution. Okay, so density-dependent factors versus density-independent factors. Panda-paw. So the density-dependent factors are panda, predators, availability of resources, nutrient supply, disease or pathogenic spread, and then accumulation of wastes. Density-independent factors are things like phenomena like natural disasters, abiotic factors such as temperature, CO2 levels, and then weather conditions. So density-dependent just means if there are more of them, these are going to cause more problems, whereas density-independent, it doesn't matter how many of the species there are, these will affect them. Not all species are equally impacted. Some species have better adaptability and mobility, which allows them to thrive or do okay. So the protecting endangered species, there's different ways that we can do it, like criminalizing poaching. So it's a super sad picture. There's a video here and a video here, an article here and a video here. You can actually check those out if you click on the link inside of the PowerPoint, which you can find on Teams. We can also do things like protecting animal habitats, factors that influence ecosystem conservation plans, things that we do. We typically create sizes, shapes, and connectednesses because we want to make sure that we keep the theory of island biogeography in consideration. Metapopulations, single large or several small, and edge habitats. And we'll talk about that all in a second. So here you go. Remember island biogeography, where their ability to migrate based on large island, small island, if they're close to the mainland or far from the mainland. If they have few species are going to be on a small distant island, there will be many species on a large nearby island. Metapopulations is where you have spatially separated populations of the same species which interact and interbreed. So the ability to go across like these different islands, they're able to interbreed and interact with the same species. If they're farther away, obviously that's going to become less of a problem, or it's going to become less likely. We can also see that if we create large reservoirs versus small reservoirs, Large reservoir is always bigger than a smaller one. One large reservoir is going to be better than a few small ones in the same total area. If you do end up going with small reservoirs, you don't want to space them too far. You want to try and keep them as connected as possible, giving them habitat corridors, because then you can have their ability to go from one to another. Typically, if you have a compact shape, it minimizes the boundary length. So this right here has a less of a boundary length than this right here. You also want to create buffer zones, which is an area that allows for a slight amount of buffer with the environment outside of it. So when you're creating these reserves, if you ever get into the business of creating reserves, or if you want to create a solution where you say we need more reserves, these are things that you can keep in mind. Edge effects are important when these reserves are put into place. So for instance, if we have plants out here, these are going to be affected by edge effects, the species that are on the outside of this preserve. So if you have an increasing percentage of the patch you'll have an increasing percentage of the patch being affected by more of edge effects. So inside, they're not going to be affected. On the edge, they are affected. The width of the edges is relatively constant. So if you have a larger area, you're going to have less of an edge effect. So creating a bunch of small zones like this, you're not going to get as much as creating one large zone. You also have to consider biosphere reserves. These contain zones that vary in allowed amount of impact. You can have a central core, the buffer zone, and the transition area. So whenever there are reserves, these are things that have to be taken into consideration, looking at like water traveling through. The core zone is in the middle. The buffer zone is on the outside. The transects are inside of the area where you can transfer from one area to another. This is just one example of Cusco National Park. So whenever they create national parks or national wildlife reserves, these are all things that they make sure to consider. That's why they're much larger usually than what you would expect them to need to be. We can also do things like legislation to help prevent endangered species. So there are examples of single species legislation. This is like the more traditional option because people become experts on an important species and they can focus their money and their resources and their efforts. So, for instance, the National Greater Sage Grouse Planning Strategy to protect the sage grouse, right? One species, much easier to focus on one species. Another example of this is the California condor. Their population crashed because of poaching and lead poisoning, as well as habitat destruction. There was a plan to capture all of the remaining wild condors. There were only 27 by 1987. And then they had captive breeding and reintroduction. They are now 400 to 500 in the wild today. So another example of a single species where we can try to protect one species. So the question then becomes, which species deserves the focused attention? Do we protect the umbrella species? Do we protect the indicator? Do we protect the flagship or charismatic species? Or should we protect the keystone species? So, just a reminder of some of those definitions of these types of species. Quickly reflect changes in ecosystem functioning. Hopefully you know that's an indicator species. Keystone has a disproportionate, far-reaching impact because it is the keystone. A flagship is popular with humans, typically based on cuteness, large size, or high intelligence, and that can raise concern or awareness. And then umbrella is the conservation and protection of these species, indirectly affecting the conservation and protection of other species within their ecosystem. If we can protect an umbrella species, we are protecting multiple species indirectly. So again, which species deserves the focused attention? Well, typically we have charismatic species that we protect, like dolphins. They're beautiful, they're pretty, we like to see them, we like to, we want to pet them. So we try to protect them. Some of the limitations of a single species approach, of course, is that if we don't protect the habitat, we're not really doing much. If we can protect the habitat, we're allowing more flexible and natural ecosystems. This allows the species relationships that we're not even aware of, and we're focusing our money and efforts on hotspots of biodiversity instead of one specific species. So a piece of legislation that went into effect to help with this is the Marine Mammal Protection Act, which prohibits the killing of any marine mammals in the U.S. and any import or export of marine mammal body parts. The Endangered Species Act was put into place in 1973, which allows the U.S. Fish and Wildlife Service to determine which species can be listed as threatened or endangered, and prohibits their harm as well as the trade of fur and other body parts. So, what is endangered? Well, endangered just means that it has a danger of extinction within the foreseeable future. So, this is an example of a map of species that have been listed as critically endangered, and the darker it is, the more species there are. Endangered species just in the United States, looking at clusters inside of counties. Hey, if we look up here, we have like 2 to 4. We're doing okay. But you can see that there are clusters in different counties depending on the part of the United States. A threatened species is likely to become endangered in the foreseeable future throughout all of it or a significant portion of its range. So threatened species are not yet endangered. Endangered species are not yet extinct. Alligators, whooping cranes, bald eagles, peregrine falcons, wolves, grizzly bears, and California condors were all saved by the ESA. So the question is it always good news when we see that a species is taken off the list? So I want you to think about that. Is it always good news when a species is taken off of the list? Why or why not? Be able to think about that for a moment. So why do we care? Why should we care? Well, there's a lot of different things. There's instrumental or extrinsic value, right? These species can provide goods and services, recreation, aesthetics, medicine and research, and genetic info. But there's also intrinsic value. This is thinking about just the right to exist regardless of the practical use to humans. E.O. Wilson said biophilia is the inherent genetic kinship with the natural world. Just the fact that we can look at species and animals and plants and have a respect for them, even if they don't serve some obvious purpose to us. So that's the end of our 9.9. There's only one more section to go in AP Environmental Science.